Quick review of Bernoulli principle for ME143 in preparation for exam 1. Definition of the Bernoulli equation. Under the following conditions, if the flow is steady, we consider a streamline, so between A and B, if we neglect the friction inside the flow, so the flow is inviscid, no heat source or sink, and the flow is incompressible, then we can write that PA divided by rho plus 1/2 VA square plus GZA is equal to PV divided by rho plus 1/2 rho VB plus GZB. So again, this is an energy equation. You have the work of the forces by pressure plus the kinetic energy of the flow plus the potential energy of the flow is constant along a streamline. Applications to estimate velocity in drainage problems, to calculate velocity from pressure measurement, that's a pitot tube, to estimate pressure from velocity measurement. It's an estimate, that we really need to remember this is an estimate for most of those applications. So here's a quick problem that we can solve with Bernoulli. Here we have a tank, pressurized tank, and that contain water, and the question is determine the height of the fluid, the height of the jet H. So we are going to take a streamline, I don't know why I say streamlines, but a streamline that starts from 1 and go all the way to 3, okay? So with this streamline, we're going to write that P1 over, here I'm going to take the height form of Bernoulli equation, plus V1 square over 2G plus Z1 is equal to P2 over rho G plus V2 square over 2G plus Z2 plus is equal to, is equal to P3 over rho G plus V3 square over 2G plus Z3. What can I simplify here? Well, starting by saying that Z is equal to 0 here at the plane in which 2 is located. So this is equal to 0. This H3 is equal to H. Now, at the top of the jet, the velocity is equal to 0. That's the terminal velocity. So this is equal to 0. At the top of the jet 2, we have gauge pressure. So P3 is equal to 0. Here the jet at the exit of the pipe is at atmospheric pressure, so therefore gauge pressure, that's 0. And P1 is 75 kilopascal minus gauge. The velocity, the level is supposed to be constant, so the velocity at 1 is equal to 0. And this is 0.85 meter. So in short, here we have 75,000 divided by 9.81, that's gravity, times 998, that's the density of water, plus 0.85 meter is equal to V2 square over 2G is equal to H. This here is equal to 7.6 meter plus 0.85 meter, so that that's equal to 8.45 meter, which is equal to h. And I can even calculate the velocity at 2, which is v2 is equal to the square root of 2gh, and that's equal to 12.9 meter per second. There you go. That's easy.